Come mi connetto? Aspettate, prima inserisco la rete.
Intanto prova a vedere se funziona. Se funziona così magari. Purtroppo questi computer.
Questo è già connesso. Quindi, se volete possiamo per accedere lì.
Però non era presa HDMI?
Come?
Cioè era presa
Sì, certo.
Ah no, scusa, sono bolletta. Ti puoi connettere? Se sei connesso ti puoi connettere.
Connesso.
Dove nel programma?
Nel programma di input, immagino.
Quindi basta. No.
Vediamo se.
Try più. To succeed to present it's extremely low.
Questo?
Sì, quella. Il programma.
Dove lo posso mettere sul desktop?
Cerca
Upload my presentation on the desktop.
What? Go to your live stream?
Sei connesso e poi puoi presentare 10. Ok, certo. Poi condividere lo schermo. Ci riesci il nome?
Mio?
Sì. Già partito.
Già partito.
Situazione consenti?
Consenti durante la visita.
Consenti, sì.
Can you use the double screen? Because
Ok, ci sono. Per
No, aspetta. Scusa.
Share your screen.
Sì, ci sono.
It's not showing.
Perché adesso però altrimenti fa
Sembrano attivi.
dovrebbero essere disattivi perché altrimenti posso fare in bombo.
Sì.
Con la telecamera puoi lasciare si presente.
E li carichiamo direttamente qui.
Tanto la telecamera c'è sempre qua. Accesa qua.
Would you like to... scusa, vuoi...
Vorrei provare.
Forse è meglio che...
Però aspetta. Ma si vede no? Così.
No, saltatemi Mauro. Ah sì, si vede, è lento.
Grazie.
Sì, vede benissimo.
So we can start.
Yes.
My name is Alessandro Plesante and I'm from the University of Sassari. And I'm going to present this session. We start with the first speaker. Davide Maestroni, Giuseppe Cappelli, Mauro D'Apuzzo and Sofia Nardoianni with this paper titled Mapping Risk Factors to Build Inclusive Roads, a systematic diagnosis for enhancing vulnerable users and persons with reduced mobility status. Sorry, but it's very, very, very little written. So this research aims to identify critical road safety risk and propose a targeted intervention to improve mobility for vulnerable road users and persons with reduced mobility. So you are? Davide, the floor is yours.
Good morning. My name is Davide Maestroni, and today I will be presenting our research titled Mapping Risk Factor to Build Inclusive Roads, Systematic Diagnosis for Enhancing Vulnerable Users and Persons with Reduced Mobility Safety. This work is a collaborative effort by researchers from Vivutech and the University of Cassino and Roma 3. Our research is a response to a growing focus and concern on sustainable transport issues. pushed by significant global initiatives like the Paris Agreement and the Glasgow Climate Pact. In parallel, there is a global push towards zero traffic death, evidenced by initiatives such as Vision Zero and the Road to Zero. Within this context, we highlight a particular vulnerable group, which is composed by persons with reduced mobility, the elderly, the pedestrian, and cyclists. And this group, all these groups are identified as vulnerable road users. So in order to protect the vulnerable road users, our project follows these key points. Firstly, to identify the critical and the safety risks. Secondly, to propose targeted intervention to improve mobility and safety for vulnerable road users. And thirdly, to apply principles of social sustainability in transportation to achieve this goal. For our case study, we choose to, as a case study area, the Nomentano Tiburtina neighborhood in Rome, who is located between the Tiburtina train station and the Termini station, which are the two main, most important train stations of the city of Rome. And this area is also characterized by the high concentration of transport stops. There are 3 metro stations, but also university buildings and an hospital. This area is unluckily have a high concentration of vulnerable road users, road accidents. So it's a spot that it's really good for our study. Our approach is characterized by an innovative hybrid and low-cost methodology that applies social sustainability principle through 3 interrelated studies that will be connected at the end. The first study is a road accident analysis involving vulnerable road users, a floating car data analysis, and a pedestrian crowding analysis to provide the 3 studies want to provide together a useful insight for policymakers and urban planners. These insights are crucial for enhancing pedestrian, cyclist, and the other vulnerable road user safety, and for promoting sustainable mobility in an urban environment. The data that we used in our studies are the road accident data. We used 2 datasets. The first one, who is more focused on vulnerable road users accident data, is a dataset that starts from 2011 to 2020, and provide data about the road accident, and in particular the location, the date, the time, and the type of accident. The other dataset is about all the other dataset is about all the other road accident, all the road accident, and it starts from 2017 to 2019, and it's not used in the road accident data analysis, but to prove the correlation between floating car data and road accident data in the Nomentano Tiburtina area. The floating car data that we used are provided by the black box installed in some cars, and provide information like location of the vehicle during the journey, the speed, and the most important for us, the acceleration of vehicles during the journey. The dataset provides also information about the weather condition during the journey and the direction of the vehicle during the journey. For the data for pedestrian and crowding analysis, the pedestrian flows are predicted by a model that is calibrated with Google Street View observation. We also use as a mathematical tool the kernel density estimation, that in our case is a kernel density estimation with barriers, because the floating car data location have to be pushed in the right position in the street, because when we take the raw data, some of the points were on buildings or on parks, and so we have to put the all the data, all the points in the street to have a better representation. So in the first image, you can see how it was before and how is and in the second, you can see how the data were put in with the kernel density estimation with barrier. The methodology that we use is an hybrid approach for which connect 3 different studies, but for the road accident data, we wanted to identify high risk area or black points, spatially mapping accident involving vulnerable road users using the GIS and the kernel density estimation that we used in all the 3 studies. These help us to pinpoint areas with a significant concentration of road accident involving vulnerable road users. For the floating car data, we wanted to evaluate the risk based on abnormal acceleration or deceleration, and we also wanted to find to prove a correlation between floating car data and road accident using the Pearson index. For the pedestrian crony analysis, this analysis assesses pedestrian accident risk by examining pedestrian flow. We integrating a configurational analysis with space syntax tools using integration as a key of network connectivity and pedestrian attraction. This integration value can was corrected by with factor like the presence of shocks in the area to better represent the real behaviors of pedestrians in the neighborhood. The strength of our approach lies in the integration of these 3 quantitative information sources, and this holistic view allows us to precisely identify critical areas and develop truly targeted interventions. In order to classify the risk of the in the 3 studies, we use the same method. We divided the area in classes. With the first class represent the class number 1 represented less hazardous intersection or streets, and with the value of the kernel which is less of the means of all the value. In for the class 5, with the class with the higher risk, we put in this class all the value with higher than the sum of the means plus the standard deviation multiplied for 6. Finally, we created with the results of all the 3 studies a risk indicator, which is for every intersection or every street or every square, the sum of the value, the class value of every study, multiplied for a different coefficient for every study, and we decided to give more value to the road accident data studies, a middle value for the floating car data analysis, and a lower value for the pedestrian crowding analysis. The result that we found about the road accident data was that we found the 5 high risk class 5 black points. So this area has a high presence of vulnerable road users road accident. The floating car data analysis demonstrated a linear correlation between the road accident data and and abnormal acceleration and deceleration. But in this area, we didn't find any intersection classified as 5, but only 3 or 4. For the pedestrian crew analysis, we found that the areas with an higher concentration of pedestrians were in the center of the neighborhood, which is the area with more services and shops. We use the risk indicator to provide for policymakers and urban planners a chart. And as you can see, we divided all the intersection and the square in 4 groups, divided for the risk indicator values. And in order to provide a chart classification that can help policymakers or urban planners to understand which are the areas that need more an intervention or investment to improve road safety. We only have one site that is classified as a group 1, but more the group number, because the risk indicator become lower, more areas are inside the groups. We also found the main causes of accident. In particular, there are the road surface condition, like potholes that in Rome are really famous, and a lack of horizontal signals, and there is also another thing that is pretty famous in Rome. There is the problem of illegal parking, and that bring some problem between pedestrian and between the interaction between pedestrian and vehicles. We found also a lot of cars that were parked near the bus stop or near the crossroads, and that push also pedestrians to adopt illegal behaviors. We found these images on Google Maps. So after have identified the causes, we suggest to use the intervention effectiveness matrix as a tool to reduce to improve the safety. We use this matrix that because can easily identify the problems and the solutions. In this base, we value an indicator that is called crash modification factors. The lower is the crash modification factor, more the intervention is efficient. So we also suggest to policymakers or urban planners to give the priority to the intervention that can solve more than one problem, and after move to the intervention that can solve only one problem, which are the intervention in orange. So in conclusion, our study provides a systematic approach to identify high-risk areas for vulnerable road users. The proposed procedural risk indicator offers a robust data-driven method for identifying accident from location by integrating accident data, floating car data analysis, and pedestrian density. This method serves as a valuable guide for urban planning and road maintenance strategies. For the future direction of this study, we want to try this method in other areas, and maybe also using trying in different road context, or also try to focus only on one kind of vulnerable road users, or different type of roads. I want to thank you for the attention. Before the question, I want to say that this project is financed by the Next Generation EU and is part of the Rome Technopole, Technopole project. Thank you.
Thank you very much, Davide. And, any question for Davide for this interesting intervention? I'm not an expert, but I would like to know how much this synergistic use of the three analysis contributes more than the individual use of the single analysis, and which is the not the best, but the more effective of the three that gave some best output in comparison to the synergistic use of all of them.
The most valuable data are the road accident data, which are the data we give more power, more we give them the highest coefficient in the formula because can provide real information based on facts. But we want to also a little bit predict which could be the problems in a street, maybe also in the future, and we think that the pedestrian crowding and also the acceleration in some areas can be an indicator of for the theoretical data of problems. Maybe the street, there is a reason in a place every a lot of cars sharply brakes or accelerate without no reasons, and that's why we wanted to integrate this system. And also, if we notice a lot of concentration of pedestrians in a point, we can maybe and that increase in times that can be an indicator for policymakers, but also only the higher presence of pedestrians can help policymakers to say, maybe we have to make larger the path for pedestrian, or so we wanted to do an indicator that is not only based on actual data, but can also help to prevent a little bit the danger. But we know that the actual data are more important, so we give an higher coefficient to the accident data.
Thank you very much, Davide. I didn't ask if there are some questions from remote, but I don't think so. I hope that we are still online. Yes. Okay.
We are all of us online, yes.
Okay. Fantastic.
Because I checked who is inside, finally. Barbara, Alessandro, myself.
Okay, just a moment.
I'm checked because maybe they don't know that there is
Chiara, I need to update my presentation in my laptop, so, or do you think? No, just to understand if I have to leave this one or.
You can share.
Okay, I will try to share my presentation in my laptop.
But it's better if I go out because I think that they need that money.
Aiutami un attimo, scheda fine sta schedina.
Scrivete sì, così può vedere.
Ok.
Selezionare, condividi,
Ok.
ci piega qua.
No, non dovrebbe partire.
Vediamo se parte. Sì, ok.
Okay.
Vai.
So I'm trying to present this this study. No, it's a full screen or not? Okay. I'm going to present this this study in collaboration with Chiara Garau and Tania Congiu, that is my colleague of the University of Sassari. Chiara, you know, is from the University of Cagliari. And this study contributes to the debate started by the Organization for Economic Cooperation and Development on the peripheral regions. And we try to analyze functional urban areas in relation to the sparsely populated areas with the proximity approach extended to at the regional scale. So we are going to propose a territorial model that we call the functional proximity urban area model. That is, of course, proximity oriented, that try to rebalance the relationship between compact and less densely populated areas. With the possible trades of services, in particular advanced services refer to the urban areas, and other categories of services, especially the dematerialized and high knowledge services, refer to the sparsely populated areas. I told you before that we are trying to start with the proximity approach at the regional scale, not at the district or urban level, and rethinking the concept of proximity at the regional level means to reconsider all the conditions of accessibility. In particular, means this is to say to consider the interrelationship and interdependencies between different urban polarities and, of course, their communities, and all the environmental, social, and economic connection. So we know that according to OECD data, about 280 millions of people live in the urban areas, and they are organized in about 110 huge urban areas, where only 10 cities assume the role of special metropolitan governments. And this situation is very far from that of the Italian regions. And because in particular the southern Italy regions are affected by demographic rarefaction. We know also that more than 70% of the world GDP is generated by cities, and this is because the urban areas contributes more than rural areas to economic growth and value creation due to the high population density, skilled human capital, and access to advanced infrastructure and services. And GDP growth is related in particular to economic growth and deployment, but also to land resource consumption and competition between territories that is not in line with the sustainable goals. Let's start from the OECD functional urban area concept. It's objectively hard to define the boundaries of a functional areas because this area must include all the areas that are economically connected to workplace community, so commuting. Sorry. And so the key infos, the key information are the density of the population and the travel to work flows. So, which are the other significant connection that we can include to define a functional urban area? In relation to travel time, we have this tripartition, and you can see that in the upper part we have a higher organizational complexity, accessibility, and integration mode travel. In the bottom, we increase the public transport and the private car dependence. So, in the 2019 ISPON report, okay, that is a cooperation program, an interregional program for territorial cooperation. This program identifies several indicators to assess the accessibility and the spatial connectivity, in particular to analyze the mobility within the mobility dynamics within the functional urban areas. But we have also interesting indicators like the primary energy consumption. We see the case in the metropolitan city of Cagliari that is coincident with the functional urban area of in Sardinia. And we see the comparison in 10 years, how it grows in 10 years. I told you that the non-objective, we need non-objective delimitation criteria to define the boundary of functional urban areas. Note that the final report of ISPON in 2020 reports that functional urban areas are considered the most stable definition for functional regions in urban environment, but they require to be updated and improved in relation to geographical specificities. If you remember the previous figure, we see in this case the energy sources, and we see that this is the new configuration of the metropolitan city of Cagliari, and we can know that the energy sources are mostly on the outside of the functional urban areas. So we can think a model that rebalances this exchange of resources and services. In particular, we see on the left the not renewable energy sources, and in this one we have the renewable one. And this is true also if you consider, for example, the treatment plants of waste or water or something else. So it's important to introduce a spatial model for rebalancing this equilibrium. But this model has as a compass, as a reference, the ecosystemic urbanism model of Salvador Rueda. In this model, urban and rural areas are entities, are like entities that operate in complementary and fractal ways. But the most important element is that this model represents a territorial governance model aiming at self-sufficiency in food, water, energy, and waste cycle. But this model, this functional proximity urban area, must promote firstly the accessibility to connect this polycentric organization with the other urban cores in an acceptable time frame. This is the model of the urbanism, ecosystemic urbanism, with the axis, the topics, the principles, the weight, and the indicators. To conclude, but I'd like also to show you some outputs of work in progress study. In this interdepartmental compensation perspective, we must achieve two things. The first is to identify the parameters and factors to delimit the functional proximity to urban areas that include also the sparsely populated areas, and strategically plan the organizational connectivity for different functional proximity urban areas. How can you do this? First of all, we have to recognize the elements of travel time stabilization to plan policies that promote accessibility and overcome infrastructural deficits, and promote stronger territorial cooperation in strategic fields, in particular in the management of the natural resources, and introducing and innovating services, not only the basic essential services, public transportation, health and education, but dematerializing and considering high knowledge services. The study that I would like to show you in brief, some analysis I have in the presentation, this case study in the Sulcis-Iglesiente region in Sardinia. A special organization through a network system of accessible nodes is planned. And the aim is to foster the interconnection among the network nodes which are linked with the places that have great potential in terms of services and attractiveness. We see several analyses that show, for example, the archaeological mining heritage. This territory is rich of this historical cultural heritage, and the boundaries follows institutional and social cultural elements to define it. Indeed, for example, we analyze all the settlement patterns, and these settlement patterns in some way are concealed because it's a very ancient organization. Then we analyze the balance of ecosystemic services. In this case, we have only supply services and cultural services in relationship with the functional urban area of the metropolitan city of Cagliari. So we can see if we need a balance between ecosystemic systems, ecosystemic services that offer this territory in relation to the metropolitan city or the functional urban area of Cagliari. Here we have several heat maps that show the personal services activities divided in amenities, tourism, shop, and historic according to the OpenStreetMap categories. And the sum of all of them reflects the socio-economic dynamics seasonally affected by the tourism flows. So we see a strong concentration in the coastal areas and in the inner core centers. Here we see the system of connection, the system of the services and mobility, and it's show that there is a significant infrastructural deficits throughout all the area, but in particular in the northern part of this region. And at the end, I'm going to show you the analysis of the accessibility by car made by the isochrones, with the greater accessibility where there is a high interposition of isochrones at 10 minutes. We can see, for example, that the most important interconnection are in the southern part. The third image shows the analysis of accessibility of urban centers by public transport flows. We assess the efficiency of the public transport services considering the density of stops, the distribution of lines across all the territory, and the frequency. And the last one is the analysis of the pedestrian accessibility to public transport stop, with the definition of the service area at 300, 500, and 1,000 meters. We can see, of course, there is a poor coverage of the territory. Other analyses we are carrying out, other analyses considering, for example, the foundings and the capacity of the territory, of the stakeholders to participate to European project. Thank you so much. This is the end of my presentation. If you have any question. Okay. If you don't have any question, I will go to the next.
I found this work really interesting. I had just a curiosity. You presented this application, this study, in particular on two municipalities. Okay, so
yes, it's more than two municipalities because it's an historical region of Sardinia. It's Sulcis, Iglesiente, and Bustinese. So with three main municipalities, but we have a lot of small hamlets that are about 1,000, 2,000, 4,000 inhabitants.
We needed to find an area that wasn't Sassari accredited because we needed to be unbiased. So
I foresee the possible difficulties in dealing with the different municipalities. So it's especially in inner areas, it's very difficult to make the municipalities dialogue.
Yeah, there is of course a lot of institutional interaction, but in this territory are present some very important networks that gave us a lot of data. That are, for example, the hiking foundation of Santa Barbara, Camino di Santa Barbara, that starts from this territory and in the years include all the territories of the Sardinia. So it started with the 21 municipalities and later consider all the territories in Sardinia, and the element of connection is Santa Barbara, that is the saint that protect miners. Okay, so it repeats all the hiking trails that are no more used for touristic works. Okay, thank you so much. The third intervention is Chiara Pinna, Alessia Torlini, Alenka Poplin, and Chiara Garau. The title is Smart and Happy Cities Towards a Definition and a Methodology to Evaluating the Emotional Perception of Happiness.
Yes, I try to share my screen, but there is Alessia Torino online. She didn't succeed to switch on the camera. She was my student, so for me it's an honor that she succeeded to connect herself. But before starting, I want to give you a wonderful news. I'm discovering now. 1 second.
We have the condition.
No, it's better because we are in a research environment. There are the proceedings online. So I share my screen. Sorry. There isn't not all proceedings, but some of them. The first, and it's the first year that is the last, and the last we are, and there is the 13 our book, I think, of this paper, and I found also there is the part 11. I saw that there is also Gerardo, so there is also the books of the other workshop. So I think that is a happy news. I discover now. You're lucky because I'm here, so you are the first that you know. So I will start with my presentation. Okay. So Alessia, if you can listen to me, I'm starting. Sta iniziando Alessia. I'm sorry, she don't speak English. Okay, so this paper is done not only with my students but also with Alenka, quindi so Iowa State University, and this idea came out last year in the same in Vietnam at ICCSA conferences, in which speaking about research, we succeeded to find a connection between my work and the work of Alenka, finding many things of conjunction together that we didn't expect. So Alenka is a really fantastic expert on games, on serious games, and I am an urban planner. So it's difficult to succeed to identify the modality in which it's possible to merge these two so different topics. But I try to work with emotion. So emotion applied in the places. And when you want to play, there is some emotion. So I don't know if you remember Pokemon. You have to go outside, and if you see the presentation of Alenka, you perfectly understand what I'm trying to explain. And oh, thank you so much. Thank you, Alessandra. And so we started to think about that and try to apply all. So smart and happy city. I am expert in smart city. So why a smart city not be also happy? Why we don't try to study a context in which it's not only functional, but I really wanted to stay because I love to stay in that specific place. So this is the roadmap, but finally I know that I don't follow. You can see, okay? So this is the roadmap of the paper. So introduction, literature review, definition on happiness, but happiness applied in urban planning. It's extremely difficult because it's not something that you can measure. So, but we succeed. Methods and tools, and definition of the index of emotional perception of the degree of happiness. This is the roadmap, and finally, conclusion. I don't put a conclusion because we are still working on that. So it's a first conclusion. Also because it's an open question. Can a smart city also be a happy city? Can we hope so? But there is not a unique reply. So I've already explained the main goal of this research. So I work also with indicators. So I try to find a modality to measure, to classify this happiness. And of course, the literature, the main, the pillar that try to speak about a city of a human scale, but to try to integrate this approach, to try to start to think about happiness. Armenia, it's not the first time that people try to measure. Maybe in the past or now they called well-being. They called with some synonyms. You understand me? Some with other words that represent the same. But finally, well-being is also being happy, is also being satisfied in the place in which people live. So I don't want to do step by step about the history, why people try to represent this. Before Alessandro spoke about Salvatore Rueda, and also with Alessandro we find many elements of connection, particularly speaking about proximity, the city of proximity. So, first of all, literature review, we try to identify a definition, but this definition go ahead in changing. But I wanted to insert a key sentence about 1962 because I repeat, it's not a new tool, a new methodology to speak, to try to identify an happiness in a city. So this is the roadmap, step by step, going in more deep detail by identifying also the modality to measure this kind of this happiness. And what was so interesting, because I also spent 1 month in Aya University as visiting professor to Alenka, was that I work with indicators and she works with another modality. It was so fantastic because we succeeded to speak about a specific topic, but by using different methodologies. So with this, we use indicators. I'm more expert. So what that we did so is to identify different indicators that can analyze in a qualitative way. And of course, we use the literature review for understanding which are the most useful, and we create also some other try to give some novelty in this paradigm. And this paper is extremely connected with another paper that we presented this afternoon, because finally here we focalize on happiness, and the other paper we focalize with the same neighborhood with the proximity approach, so 15-minute city and so on. So I try to split, but finally it's the same analysis. So this is the quantitative analysis, and we try also to identify also a modality to analyze the manifestation of joy, the stress, and so on. And this is a kind of analysis. The other one was a survey, qualitative analysis, in which we try to collect the different aspects and the different emotion and perception of this particular neighborhood. So we analyzed San Benedetto again, because with some colleagues I work so much with San Benedetto. Karen, you have only to be in Cagliari, because I spoke too much about this city that finally you must go. So this neighborhood is extremely interesting because it's in the middle. Is in the city core, and it's also a neighborhood in which there are many amenities, many points of interest. There are many people that love to go on food, and it's a good neighborhood to study because has many elements, practical elements, practical and also easy to study. So for that reason we use this neighborhood. I don't go in the detail for all kind of analysis that we go, and I really also need to thank my students. I don't know if Alessia and Chiara, because they believe in this project. They believe so much, and we started with just a little part of this analysis, but they love so much, and finally they wanted to go in the detail, and we succeed also to do in detail this kind of analysis. And we did this analysis. We merged the qualitative analysis, and finally I want to go directly to the conclusion, because if you want to know about the kind of analysis, you can send me an email and we can also work together. What that we can find is extremely interesting. First of all, people have a different perception of this neighborhood. And as an urban planner was extremely interesting, because if you, without this perception analysis, was so homogeneous, the analysis, by considering both the qualitative and quantitative analysis, but considering also the perception, something changed in this neighborhood, and it's possible to understand better also the feeling, because if I feel that a street is not fair to go in that street, could be perfect, but I don't go, absolutely. So with this kind of analysis, we understand better the modality to intervene in a specific part of this neighborhood. So I don't want to spoil too much, because I try to do, but this afternoon I will go ahead with this analysis, because if I go ahead to speaking, finally I said all now. So so I got just that. So why the games can help to improve the places, and was this a key point of this paper. And I repeat, I need to thank so much Alenka, because we try to study that playing can change also my original perception of a specific place. So playing, you can change this modality of thinking of a specific place in a bad way. So this could be a modality to create a happiest city than the what that we think to see and to have. So the conclusion. So, but just some curiosity. So if you can follow me the next session. We try to create a global index for measure the well-being, because I am a planner. It's not I can say a technician word, happiness. So well-being is okay. And later I will explain better the modality of measure the happiness, the well-being, or happiness, both. Okay. And I conclude with this sentence. I don't want to give you a reply, but just to think about can a city be both smart and happy? For me, yes. I believe in that. I concluded. Okay.
Is there some question?
Yeah, thank you so much for this great research. What I love most about it is that it seems
really designed with an application in mind, and sometimes we focus so much in technology that we forget how more human basic principles can do much more for our well-being and how we interact in the city. You mentioned that you are going to present the global index.
Yeah.
I'm curious about that.
So you have to follow me.
It's not my section, but otherwise I will follow. My question here is, based in your experience, can we transfer this global index to other contests, or is very much focused on context and culture of that specific region? Because I will be
It's a really big question. Because what that I discovered also with studying with her, because in the previous paper we worked also with an Indian person, Dongerico with the connection. For her was a time for me for him 7 o'clock.
Yeah.
You know what I say?
Yeah.
It was basically it was a moment, a big moment. But what did we discover is that the feeling, also the name of the feeling, changed by countries. It was incredible. For instance, there are so many nuances. And I discovered because for me happiness is happiness, but no, because for instance, I don't remember exactly which nuance of happiness, but for the Indian person, he didn't call it in that specific way. I repeat, it's a really big,
and
so
within
subject,
the subjective very
yeah, but finally we identify some that were good for all.
Yes.
So
And of course, there's no be able to compare. Let's say I'm happy, I feel the same as when Chiara is saying I'm happy or I feel joy. Is this the same, way of feeling and then the other thing is we are choosing words for something and whatever we feel for the word that maybe the Indian person chooses for a certain feeling might not be the same word that I would choose for fun. So there is like a lot of fuzziness in emotions and in research. So
yeah,
they have fuzzy objects basically.
she showed which she identified many feelings, and the opposite, the more I can say, the more strong or the more the less strong are similar, but in the middle there are many nuances that is subjective that is really different times. So it was intense because for me also the different nuances for me was a kind of labeling something of objective feeling, but it's not really. So it's so interesting. There is a word inside. So and I already started now. So but we can go on. Yeah, why not?
Chiara, I have a
Yeah.
short curiosity. How can you balance the perception of happy city spaces in consideration of other users than the general resident, for example, for people with reduced mobility?
Also, this is a big question because the first step of this analysis is try to understand the perception of residents and also the people that, like tourists, like visitors, like users in general. Visitor, I don't know, maybe it's another. Sorry. Like users, because the user can have an unbiased way to see this particular part of the context, and the residents put their emotion, so we can have both. But I didn't consider yet
People with reduced
yeah, but could be really. I am the first
No.
step,
I was
so
just
but we
curious.
can work. No, also with her because she is a special motive. So it could be many ideas that can come out from this
I think
research.
that we need
Yeah.
different ways to
Yeah.
evaluate this.
But could be also interesting to identify the difference between male and female, because there is another word. It's correct, Gerardo, because I studied with female analysis and it's another work. So the idea came out, so I started with this.
Okay. Thank you very much, Chiara.
Thank you.
Now the floor is for Barbara. And Barbara Caselli. I'm old, sorry.
It doesn't matter. Oh, there are so many papers, so please.
Altea
Pane bianco,
help me please.
Altea pane bianco,
Silvia
La
La
Placa,
Placa
e
and
Rossella
Rossella
Laera.
Laera. And the title is GIS-based accessibility and safety assessment in small historic center in areas. Pilot application in Sigliano, Matera,
Sigliano Matera.
and interoperability with digital twin. This research experiments with a possible decision supporting evaluation process in a small historic center in Sigliano Matera, and set up a methodology to plan appropriate intervention aimed at improving accessibility and safety. Thank you, Barbara.
Se va bene io puoi trovare la chiave. Perché è questo? Questo qua. Sì. Niente, provo con la
C'è uno spazio per...
Il tuo computer?
Sì, vediamo.
Ah no, sì.
So, I have to do
Yeah.
here.
È un PDF, se vuoi
Un
prendere,
PDF.
facciamo dal mio.
Sì.
Sì, grazie.
Can I?
Yes.
Yes. Is it good?
Non hai condiviso, però? Non hai condiviso.
Adesso ricondivido. Which one? Okay.
Diventiamo esperti in tutto. We became so expert in Turkish language.
And the presentation or room?
Solo in mezzo.
Okay. Grazie. Okay, thank you so much. Some technical problems. Starting point is always a must. Okay, good morning to everybody. Today I will present this work that actually is framed in a national research project funded by the Italian Ministry of Universities and Research with the Next Generation EU funds, actually in the framework of the National Recovery and Resilience Plan. And I will start with briefly outline the aim and scope of this general research, then the methodological framework. I will walk you through some first results on the pilot application, and finally some insights for future developments, because we have some months in the future to go on working on this. Our research actually addresses some social territorial fragilities and in marginalized and peripheral contexts. So again, we talk about sparsely populated places. And these spaces, in particular in these areas, we in particular focus on small minor historic centers that are generally characterized by declining population, loss of services, environmental fragilities, of course, and reduced territorial attractiveness. Actually, this territory also have, let's say, a large amount of resources in terms of historical, architectural, and landscape value too. So in fact, there are a lot of policies dealing with territorial inequalities, trying to strengthen the tourist attractiveness, but also community empowerment. For example, the EU cohesion policies, and again at the national level, because we focus on Italy, of course, in this case, inner areas, the National Recovery and Resilience Plan, and the National Strategy for Inner Areas. During our studies, we highlighted a gap actually in the literature, focusing a lot on territorial accessibility. So how can I reach a minor historic center? How a tourist can reach a minor historic center? But few studies centered on how community live the public space and how they perceive and feel safe in the public space, considering also that these areas are characterized by aging, elderly people live there mostly. So to try to fill this gap, we try to set up a GIS-based methodology to plan and prioritize intervention in the public space, trying to improve accessibility, safety in public spaces. Working on three main indicators, I will present them in the next slides: walkability, usability of spaces, and vulnerability. And finally, we try to explore within the national project the potential of this assessment to be integrated in a digital twin. So using it with digital twin technologies for planning management and future empowerment of planning processes. Of course, I am an urban planner. I didn't present myself. So basically, we started trying to define three main core indicators, and we started by consolidating the existing literature that I said is not so large. And we defined three main indicators: the usage intensity, measuring how public space can support mobility and also social interaction; walkability, for evaluating pedestrian safety, of course, the practicability and also the comfort in the public space; and finally, the third of the vulnerability, that is a key component generally to determine the potential damage of people, indicating the predisposition of the system, urban system, to be affected by possible harmful events, in this case, abandonment or even environmental risks. This is in detail how we evaluated the three indicators. Each indicator actually will be calculated with a series of factors that you see here in the slide. So for the usage intensity, for example, the access to specialized building or the density, possible density of abandoned buildings along space, the presence of social hotspots, and so on, going to the vulnerability, in which we evaluate the spatial configuration of the space, the density of buildings with possible signs of structural deterioration, and the presence of retaining wall or downhill slope of the space. This is just an example, but you can see better on reading the slide. Finally, we improved and worked on implementing a spatial information system to collect all these data. And actually, the diagram you see here in the slide is about the structure of the spatial information system we implemented within the national project, research project. Actually, to perform the assessment I present today, we used only three interrelated, correlated feature classes concerning open spaces, fronts, and buildings, collecting data, of course, on the built environment, morphological, physical characteristics, and also social characteristics concerning the open spaces. And we performed actually a collaborative data collection. So in here I have to thank also the colleagues of the University of Basilicata, with which we are collaborating in the research project, that helped a lot to collect all the data we need to perform the analysis. We divided the open space in minimum operational units, and then to each operational unit we associated qualitative and quantitative attributes. Finally, we combined the previous indicators to calculate two main indexes that can help in the supporting, let's say, the decision-making process. The first one is the accessibility index, to be considered under, let's say, ordinary conditions, and it reflects the general accessibility of a space for both residents and potential external users. And the second one is the potential harm index that assesses and defines, let's say, the possible risk or damage alongside hazard, indicating the predisposition of a system to be damaged. We applied this methodological framework to the case study of Stigliano. This is a minor historic center in the Basilicata region, so we are in southern Italy. And of course, it is an emblematic case study because it has basically the main characteristic of an inner area. So, of course, it has a lot of historical, architectural, and landscape value, but of course, it is affected by population decline, abandonment, hydrogeological risk. In particular, in the project, we focus on this pilot area in the city center that is actually subject to a transfer plan because of the high vulnerability of the space. And this transfer plan that was established in 1987 brought people to move away from this part of the city, let's say, worsening the degradation process of the built-up space. So we wanted to focus on this area in particular, try to document the actual architectural heritage, cultural heritage there, and try to also prevent some damages for people that are unfortunately still residing there, because someone is still there, because they never moved away from their houses. So this is the first application of the, for example, usage intensity. This is the map, typical map. We read, of course, the red color indicates the worst condition, while the green, the better condition. And we combine the different attributes, as you can see here, synthetically reported. So this first indicator is the usage intensity. So of course, the green parts highlight the hotspots, social hotspots, where we have a higher density of functions or specialized buildings or possible places for gathering. In fact, for example, here we have a church. This is one of the main hotspots of the historical center. This is the walkability map. Of course, again, there are a lot of attributes that are being combined with rules and thresholds. And again, the green ones are the more walkable, and the red one, the less walkable. And the vulnerability. We validated these results recently because we went to Stigliano in May. And so we went there with the final results of this study, and we validated these results. And I think they are quite accurate in representing the real, let's say, perception of the space. In particular, in this space, we found some building collapse that invaded then the public space. So this red spot is actually a real dangerous core. And finally, these are the resulting index thematic maps. This is the accessibility map. And again, we combined usage intensity and walkability in this case. So where we have very high usage intensity and high and good walkability. Basically, the accessibility index is green, so it's good, and the orange one, okay, is obviously the opposite. And finally, the index of potential harm. And again, we assessed the worst condition where we have very high vulnerability and very high usage intensity of the space. So we hope this is an instrument that can help also the public administration to, let's say, set some priorities for intervention on the built-up space, or just putting restrictions, okay, not to go in the most dangerous parts. And again, we started with the integration of this spatial information system that is useful to assess the quality of open space with a 3D digital model. And this is a work in progress. Actually, we succeeded in integrating the spatial information system and the 3D model that was provided by the University of Pavia, another partner of this project. And we think that this could be a good foundation for developing a full digital twin for the center of Stigliano, trying to automate the documentation process that right now we performed on site, so going on site collecting information, and facilitating also the scalability and updating of this process. And also sensors could be installed in the city center, trying to provide some simulation, time simulation of, for example, building degradation or building movement and so on. So finally, I'm going to conclude this method that we think is rigorous in the methodological, let's say, approach, but yet is user-friendly and can be easily explained to local technical office. I have to precise that Stigliano is also the leader municipality of the inner area Montagna Materana, and is probably the one that has the higher capacity in terms of administrative capacity. Okay. So the tool allows, the tools we developed allows to highlight the criticalities and potentialities, of course, in the public space, trying to identify possible modes of intervention. Of course, to go on with this process, we would like to add additional data on transformability of the space. In particular, we need to deepen the land ownership, land regime that in historical center is very difficult to define. So it's a very difficult task, but it's indispensable for operational planning. And finally, we want also to involve more the community to collect their perception, especially of the walkability and usage intensity. And finally, we appreciated this good interoperability with between the spatial information system and the 3D digital model, but we have to make more steps toward a full digital twin. Of course, the possible barrier are the community perception that is not fully captured yet, the cost right now of the extensive field survey, and also the lack of capabilities sometimes of the public administration. So the next steps are basically starting with capacity building activities. And within this project, we are foreseeing capacity building activities in the next month with the technical staff of the public administration. We also want to strengthen community involvement. We tried in the first stages, but we found a lot of barriers. And probably there are problems between the public administration, actual public administration, and the community involvement and community, let's say, yes, participation, okay, in the public life. The prototype of this spatial information system and 3D model will be actually publicly accessible in the future through our virtual platform that will be enriched also with other information that could be useful for tourism improvement. And finally, this application, we hope we can upscale it and then replicate in other contexts to test its robustness. And thank you.
interesting presentation. Do you
There
have
are
some
questions, of course.
Congratulations, Laura, for this fantastic project. It's a really interesting. I have just a suggestion because I did many years ago some interviews in really small areas, and the unique modalities in which we succeeded to have this interview is being introduced by local administrator and by the people that they already know. This was the unique modality to try to succeed to have this interview. So could be a suggestion.
Yes, actually we tried because we have as main stakeholder the public administration right now, but it's very difficult for them to involve people. We also organized a public event, so open to the community, and the idea was to create some discussion tables with people, but no one came. Just 5-6 people, 6 persons, so very small. But we succeeded instead walking inside the city center and talking with people, so interviewing directly there. So we have to change probably the modality.
Even blog notes.
Yes. No, we also recorded that. We asked for permission, we recorded, and these interviews, let's say, will be available also in the virtual platform. But we have to improve, of course, this aspect.
Yeah, thank you so much. I really enjoyed your presentation. I have one question, or maybe, a question on your indicator usage intensity.
Yes.
And I see that you said, well, the more intense or the higher, the better, right? It gets green. Is that correct?
Not the better in this case, but the more exposed, because if it is it has a high usage intensity, it's possible that more people gather in this place.
Yes,
so it's more exposed.
So it's the more exposed, but the greener it gets on your maps.
Yes.
Yeah. So I would like to kind of maybe inspire them, because sometimes the more they gather, the more exposed, it might also go into the negative. Not be green, because if we think about Venice and so many people visiting Venice, at a certain point it keeps the usage intensity, it goes green, but at a certain level it would go back to red because maybe it's too intense when there are too many people. So I wonder if you consider that, or you could for the future, to what is the level of till when it's green, and then that again, back to the discussion with Chiara, could also be a matter of a perception, because sometimes I might not want to go there where it's a usage intense.
Yes,
it's
of course.
An inspiration for.
It's quite true, and thank you.
Yeah.
In fact, we thought a lot about this, but we tried to develop this methodological framework within this specific minor historical centers. So cities like Venice, for example, we cannot apply this kind of probably methodology. It's quite different. That's why I said we try to consolidate the existing literature. We found very few references for minor historic centers, because there are a lot more for large cities. So actually we thought about this problem, but we tried to focus more on this context. And the second, yes, what was the second suggestion? I don't remember.
Also, that the usage intensity, the perception could be
the
different.
Perception, yes,
right?
of course.
I might feel like I'm introverted, and I might not want to go where it's intense use. So for me, the green would be red.
Yes,
right?
Of course. Yes, and that has to do with the community involvement, of course. So we need to improve also this with more interviews or possibly questionnaires to involve people and collect their perception of the city use. But
what I actually am saying is that this usage intensity might not be so green-red clearly.
Maybe we can
in that
try to
sense.
change.
It could be more subjective perception of it, and then at a certain level of intensity, green could go red because it's too intense.
Yes, of course.
These are the two things.
Okay.
Yeah.
Thank you.
Allora, I have a short question. The digital twin model are usually tested in urban planning for big cities. How can they contribute in this case in a fragile and low density place to improve the planning, the intervention planning in accessibility and security? Which is the contributor of this model?
Yes, okay. We are thinking about digital twin in particular for monitoring the, let's say, building movement, we call like that. Because as I said, this is a transfer plan zone and has a lot of fragilities in terms of building deterioration because of abandonment. Actually, there are recent geological studies that assess and question the previous law of 1987 that put the transfer plan and provided this transfer plan for the area. But unfortunately, I don't see future possibilities to remove this plan if we do not monitor in time what is actually happening to the built-up environment in this area. So we think that maybe with a digital twin, we can help this process of continuous monitoring. Of course, it is very difficult. It is also a, how can I say, a speed up. So it's very challenging because of the dimension of and also the capacity of the public administration. So that's why we are three universities and we are trying to collect ideas to make it possible. Let's say.
Thank you very much. So we are going to the last intervention on remote.
Okay, yes. No, è quello che mi sta. Io non riuscivo a controllare lo schermo.
Okay. So the last intervention is Giuseppe Cappelli, Sofia Nardoianni, Mauro D'Apuzzo e Vittorio Nicolosi, and the title is Pedestrian Crash Severity Prediction and Contributory Factors Analysis by Using Machine Learning Methods. Giuseppe, the floor is yours. So if you hear me, give me a sign.
Yeah, I can hear you.
You can start and share your presentation, please.
Okay. You've seen the presentation, right?
Yeah. Okay, perfect. You can start.
Thank you. Hello, everyone. First, before starting the presentation, I would like to introduce myself. My name is Giuseppe Cappelli, and I'm currently a research fellow at the Department of Civil and Mechanical Engineering at the University of Cassino and Southern Lazio in Italy. In this presentation, I will show you preliminary results of this model that we use to predict crash severity, and our preliminary result in this project in which I was involved in the last year, that it's called the Emotives project, that aims to combine and leverage machine learning and artificial intelligence technology to improve road safety. In this presentation, I will show you which are the main models used and analyzed to predict crash severity. The reason why to focus on road crashes and in this particular case on pedestrian crashes is due to the more and more attention paid to national and international government. One of the last plan that is called the Decade for Action for Road Safety 2021-2030 is an example of this increased attention toward safety. Within this plan, the within this plan, the aim of this plan was to reduce road traffic death and injuries by at least by 50% in that period frame. And the attention was essential in this plan to understand what to do to reduce this road crashes, how to do it, and especially what to do it. In this context, university and government play a substantial key role. If you want to study road crashes in general, and so pedestrian and cyclist crashes, we have to be aware that there are a lot of variables that influence road crashes. We can split these variables in six family. For instance, we have roadway related characteristics such as type of the road or surface condition, environmental conditions, so weather, and so on, crash scenarios, and so which are the interaction, for instance, between vehicle and vulnerable users, driver characteristics, and mainly age and gender, pedestrian characteristics, so again, age and genders, and also vehicle characteristics. For instance, if we have a pedestrian hit by a car, or for instance, a pedestrian hit by an heavy vehicle, the outcome will be different. So we have to define different vehicle characteristics. If we want to if we want made and perform analysis toward a risk-based approach, we have to be aware that if we want to evaluate risk, we have to evaluate all those variables that we have seen in the previous slide. And if you want also to evaluate risk, you have to evaluate hazard, vulnerability, and the exposure. From a transportation engineering view, we can see the risk as a product of hazard, vulnerability, and exposure, but these three terms are translated and moved in a different way. We have first exposure, then hazard, and then vulnerability. If we want to focus on exposure means the number of road users, and so the probability of having a road users exposed to risk. If we move to the hazard is seen as the conditional probability of having a crash, and so the number of dangerous scenarios that could be happen. And lastly, we have vulnerability, that is the probability of having a particular crash outcome. So if the crash leads to an injury or to a death outcome. So in this presentation, we mainly focus on vulnerability, and so the aim of this paper is to evaluate crash severity. So if an accident happen, if a crash happen, if this crash lead to a fatal or a non-fatal outcome, for instance. To perform such type of analysis in agreement also with the objective of the project in which we are involved, we use several machine learning approach and several machine learning algorithms. The models that we use are listed in this slide, and in particular we try to train and test linear discriminant analysis, quadratic discriminant analysis, k-nearest neighbor, decision tree, random forest, and support vector machine with several kernel. So after the data collection phase and after the preprocessing phase, we trained and test the model by splitting the dataset into subsamples. The 70% of observation are used to train and so to calibrate the model, and the 30% of observation are used to test and so validate the model. Then we compare the performance metric of all these models, and according to these performance metrics, we choose the best models. Best model, sorry. Going to the case studies, we focus on the pedestrian crash accident that occurred between 2030 to 2020 in the city of Rome. The first analysis that was developed was a descriptive statistical analysis. On the graph on the right, we can see which are the main, the most frequent crash scenarios involving pedestrian. And according to this more frequent crash scenario, we perform also the following descriptive statistical analysis. As we can see from these two graphs here proposed, the vast majority of pedestrian crashes happen in off-peak hour, according to if we think, for instance, to a vehicle demand pattern. So in a way that there will be more pedestrian crashes when the demand, the vehicle demand is lower, so during the off-peak hour. If we perform a statistical analysis based on a weekly time period, we see that there is a higher number of pedestrians involved in a crash from Monday to Friday, and less in the weekend days. Also, road characteristics play a key crucial role. So it's essential, as we have seen before, to take into account road characteristics, because if we can see in this slide that a higher number of road crashes happen on two-way road carriageway. So we have two vehicle flow that came from two different conditions, and so there are more interaction between vehicles, and also more interaction also with pedestrians, because they have to face two different flows from two different directions. And this is also true when we see what happened on straight road, for instance. On straight roads, the number of pedestrian crashes is very high compared to a curve or traffic light intersection. going if we focus on the other characteristics, and for instance, if we see that if we have vertical and horizontal road signage, uh, in these particular scenarios, the number of crashes, pedestrian crashes, is higher, and the number of crashes is also higher when the road surface is dry and not wet. But these results are something related to statistical analysis. So with statistical analysis, we assess only the frequency of that particular crash scenarios in in the overall conditions. If the weather is a sunny weather, there is also a higher number of crashes, and the vast majority of pedestrian crashes lead to injured pedestrian. And this is to the fact that pedestrian crashes that lead to death are a rare event. Going to the results, and in particular uh, to the results obtained with the classification machine learning algorithm, we made a comparison with a prior study that we have conducted last year, and in this case, we have reached some improvement. For instance, we have trained and tested two additional models, and we have also improved the overall performances of the model. As we can see from the table, the best model according to the F1 score, that is a score that could be similar to the R square, that is a coefficient that give how the model is accurate. According to this F1 score, the best model is the random forest. In order to make another step forward, uh, we performed also variable importance analysis, and we used four different methods. In this slide, we'll see uh, by using the rock curve method and the built-in tools in the decision tree algorithm, we can see that both pedestrian age, pedestrian gender are selected as the most important variables related to pedestrian crashes. And this is also confirmed by the random forest algorithm and from the support vector machine with linear kernel. And we can see that among the top five, six variable, pedestrian age and gender play always a crucial role. So, uh, so these two variables are,
Giuseppe,
yeah.
Giuseppe, excuse me. Can you go to the conclusion in a few minutes, please? Thank
Yeah,
you.
I'm to I'm brought to the conclusion. Okay. Um, okay. To be brief, in this presentation, I have shown you what model we have used to predict crash severity. I have shown you the main statistic and also variable importance analysis, but there are some limitations of this study. And for instance, the main limitation is that with this variable importance analysis that we have performed, we know only which are the most contributory factor, but not how these variables are related to fatal or non-fatal outcome. And in the future, we hope to improve model performances and also to improve variable importance analysis. Thank you.
Thank you very much, Giuseppe. Do you have some question for Giuseppe? Any question in remote? No. Okay. So thank you very much. This session is closed, and now we can go to the event that now is still is quite starting. Thank you very much. Have I to close the laptop? No.